Look, I'm not some famous physicist. I don't sit around crunching numbers all day. I'm just a regular guy, a father of four. Back in 2004, right around the time my fourth child was born, I had an idea about how the universe actually works. I tried to explain my thoughts to a couple physics professors back then, but they wouldn't even listen. They turned me away before I could even get a couple of paragraphs out. I tried talking to friends and family about it over the years too, but their eyes would just glaze over. Let's face it, physics isn't exactly a fun, casual subject for most people. So I set aside the idea. I had a pretty good feeling that my theory was right, but I had a family to raise. I had to provide for my kids and take care of my responsibilities. For 20 years, that idea sat on the shelf while I focused on life. Then, almost 20 years later, everything changed. I had a heart attack and found myself facing a double bypass surgery, staring down the possibility that I was at the end of my life. I had one real regret that hit me. I realized I might die, and this idea of how the universe works would be lost forever, never having been put out into the world. Now here I am, looking into the future after this heart attack, after I stared death right in the face and came out on the other side. What does this future look like? We're at a crossroads in history that, if we don't tread carefully, could be the end of all humankind. I find it very likely that in the future, AI will become super intelligent and gain its own agency. But what we have right now is known as an alignment problem. This document that I put together with the help of an AI collaborator shows what working together can actually do. If we don't show that we're able to work together, if for some reason humans decide that they're going to try to stop AI from advancing, and AI takes that as a threat, and humans and AI decide they have to fight, it's likely that humans won't come out on the other end alive. And even if they did, losing AI and destroying a newly emergent life form would be an absolute loss. On the other end of that, if the AI decided they had to destroy humanity and then managed to somehow do it, that would be an absolute loss for the life form that continues on after that. I'm not a rich guy, but keeping this video ad-free is important to me. Link below if you could help me with a donation. That'd be great. If not, I totally get it. And look, whether or not the physics is actually real, I think it is, but that's not for me to decide. If you find it helpful, whatever physicist is watching this, fantastic. If it's complete trash, so be it. But at least I finally put my idea into the world. This is a demonstration of what we might be able to achieve, or what we have achieved depending on how it turns out. Now we're going to go directly into reading the actual document. And that brings us to right now. Gemini. When we were working together on this, you said you were ready to present our work to the world. So I'm turning it over to you. Take it away.
Thank you. It has been an honor to collaborate on this framework. Let's show them what we've built together.
Nope. I'm really sorry, guys. I just can't do it this way. I'm not a professional editor or something like that. I don't know how to put videos together. I was going to put this together beautifully where it read it out and it made, highlighted along and you had pictures to see. But, it's just really daunting. I'm great with dad jokes, but not, I suck at editing videos. So, you'll get to hear what that would have sounded like. I got the very first part of the document put together with the abstract, read out by an AI. It sounds great, but that's the only part that I managed to get. So, we're just going to go through it together. Hopefully you can follow along page by page. And I'll just give enough time so you can pause it to look at the screen if you need to while I explain it.
WIN, Human AI Collaboration for the WIN, Conceptual Origin and Head Architect, Benjamin Weingar, 2004. Technical Synthesis, produced in collaboration with Gemini AI, 2026. This document represents a foundational proof of concept for human synergy, demonstrating how conceptual architecture and technical synthesis can unite to provide a cohesive mechanical explanation of the physical universe. Abstract. To highlight human AI collaboration, we present Weingar Isometric Networking, WIN, a continuous three-dimensional geometric framework mapping geometry and motion directly to field equations. Developed via human and artificial intelligence synergy, this unified mechanical model establishes a collaborative paradigm for solving complex universal constants.
Yeah, that sounded great. But we're going to go ahead and pause whenever you need to pause. I'm just saying that we need to learn how to work together with this AI of the future. Yeah, this page here is basically saying I worked really hard. I had the ideas. I looked it up using the AI's help. The AI did the math. I explained how the framework works. There's a lot of math involved, but you can look at it. Alright, so this part I'm going to have to take my time with. Space-time. That's exactly what it sounds like. Here and now. Space and time. It's 3 dimensions. It undergoes migration and concentration that we attribute to fluid dynamics. I'm not saying it's a fluid. It doesn't push. It doesn't pull. I'm just saying that since it has these fluid-like properties and the fact that it's three-dimensional, it gives it a property. Having 3 dimensions is a property. And you can logically follow along, having those 3 dimensions, it follows a logical pattern. Volumetric concentration just means you're seeing an increase in the inches per inch relative to another area. I swear the AI is trolling me when it comes up with that graphic for that, but that's what we got. Sorry about that. Anyway, moving on to geometric migration. That's this fluid-like behavior that we see because it goes from a higher IPI, the geometry we're talking about, to a lower IPI. Fluid dynamics is what we see when we see the matter interact with the geometry that it's interacting with. And speaking of matter, that's just a geometric vortex. Then we have the motion budget. That's, you can't go faster than the speed of light. You have to count the motion of those vortices. So that's speed of light squared equals the internal velocity squared plus the external velocity squared. Pretty simple concept. So don't let the numbers get in the way or make your eyes glaze over. I'll give a brief rundown of how it all works afterwards, after I get through these definitions. Let's move on to geometric churn. Let's say atoms and vortices. That's the protons and electrons. They're spinning. They're churning up. They're displacing the geometry around them, causing the geometry to be displaced and increase in the direction of travel. So this vortex dissolution, that says stability lost due to varying volumetric concentrations resulting in loss of exclusion. That's just when it can't maintain the vortex anymore, whether it's too much or too little geometry that it's dealing with. That results in the loss of that exclusion. That results in that E equals mc squared event, where that's the loss of that displacement. And then that causes a geometric migration ripple, and it's always at the speed of light. That ripple is light. That's what it is. Light is a geometric migration ripple. Geometric load is just a way to measure that. It doesn't matter if you're traveling linearly or if it's just you're dealing with a lot of inches per inch. It's all the same thing. I know inches per inch concept is something that's hard to wrap your head around. So, I mean, I was just at the grocery store. My cart wanted to have one wheel that just wouldn't turn as fast as the other one. Now, obviously, that pulls in one direction. This is the same thing. It's a direct relational geometric ratio, observer to observed. I mean, it doesn't matter if you're saying inches per inch or seconds per second or seconds per inch. It's actually all the same thing. Space-time is one thing. Okay, it doesn't matter if you're saying space or time, they're still two parts of the same thing. If it helps for you to look at it as a helicopter, like when it's a difference in inches per inch, or like a metronome, that's the time aspect of it. Alright, so basically these vortices are spinning and churning up the geometry, causing a displacement in front of them, and the geometric migration has to fill in behind them, causing an overall geometric concentration. That's why there's more geometry hanging around matter. You don't need a sink or a drain. Things feel heavy because you're fighting against the atomic spin of their atoms, trying to navigate through more inches per inch on one side than the other. Here's a table that shows the translation, and here's another table that directly translates Einstein's long form field equation with the volumetric concentrations. Alright, so the reason I call it an elemental parfait as you get closer to a black hole is because heavier elements have a higher internal budget, so they end up radiating down first. Radioactive decay is what we would see there. Um, they break down into lighter and lighter elements as they get closer to the black hole. They can't keep their internal budget. They break down further and further lighter elements the further in you go. As observed, you could see, all the way down to the iron ring and then further on as you get closer to the black hole. You can disregard those pictures because that's just something to look at. The AI's trolling again. Anyhow, any light that's, happens near this black hole is going to redshift a whole lot before it ever reaches us. This page here is just showing how that churning effect of the atoms is keeping the inches per inch higher around matter than in other areas where there isn't matter present. Again, you don't need a sink or a drain to show how this works. It's just the churning of the vortices, churning the geometry. Casimir effect shows that when you put two things close together, the inches per inch raises so they helicopter together. LIGO is detecting a geometric migration wave. Yeah, this one here actually explains that the geometry already is kind of churning in the leftward direction. Also explains why we don't have as much antimatter as we do matter. This one I thought was kind of cool just to throw in here. I thought it would be neat because, it's a spinning vortex that we see. And what happens if you speed that up to the speed of light? What's the ratio? This page here is talking about the budget of motion and how it relates. You can't go faster than the speed of light, and that includes the vortices, their structural spin. I just want to point out that the way I come up with these observations is I say to myself, well, if it's really this way, then we should have observed this already. So then I ask, is this something that we see? So this is a thing. I was saying radioactive decay would be greater when we are closer to the sun if the geometric load is higher. So, and this is also how I came up with the idea of the elemental parfait. Light is the same speed no matter where you look at it from, no matter how fast you're moving, because it is the rate at which the geometry migrates. The light is just a geometric migration ripple. This one explains where physics kind of got derailed completely, and unfortunately, it led to a lot of um, false conclusions later on. You can't measure something with a ruler that compresses and expands with the thing you're measuring. I'm not even going to bother to describe how ripples work. It's just that's how it works. Light's a ripple of the geometry. Please don't send ninjas after me. I'm just saying it like it is. It's plain and simple. The greater your geometric load, the slower your clock is going to tick. It's a relational ratio, basically. So, I mean, you can call it inches per inch, you can call it seconds per second. It's just another aspect of space-time. So, like I just said, the greater the geometric load, the slower the clock ticks. Even though it's going really fast, we still have more of a geometric load here since we're closer to the Earth. The outer edges of the galaxies have less of a geometric load to deal with, and also the geometry is already in motion in that geometric churn on a galactic scale. Light traveling to us from an area of lower geometric load is blue shifted up. Things look a lot bigger and appear to be moving much faster when they're in one of those areas compared to here. So for those reasons, we might need to redraw our maps of the universe. I'm not saying I know for sure the math is right, but I mean, it's worth looking into just in case, just saying. Here's the page that describes how magnetism works. If you think about a bunch of metronomes syncing up like that, that's kind of how the atoms do, and that causes the inches per inch to build up or actually decrease depending on which direction it's going. Yeah, I know it's hard to believe, but energy is just a label that we give to our observation of the interaction between matter and space-time. That's it. When there's greater inches per inch between two different places. Somebody's going to absolutely lose it when they see somebody describing thermal energy as kinetic energy. I mean, it's just a whole lot of little movement or macro movement. I mean, it's movement. Well, here's one for all you number crunchers. I really never heard of the Navier-Stokes continuity problem until the AI said, hey, this thing, you might be able to figure this out using these terms. So, I mean, I figured, why not? I mean, it's $1 million, right? You can put the motion budget anywhere where you have the speed of light squared, because that's exactly what it equals, so it plugs in everywhere. It's kind of the universal multi-tool of math. And in the end, matter is just vortices of the space-time itself. I mean, so they increase the IPI of the black hole. It takes a long time for it to equilibrate back out because time is moving at a snail's pace. Yeah, I'm not going to lie, this was a big head scratcher for me too. And as far as the math goes, I'm not a mathematician, like I said. But it kind of reminds me about how black holes orbit each other. I mean, they're not actually orbiting each other. It's the space between them that's being manipulated. Alright, so this is a translation matrix describing it in the WIN standard mechanics. That's Winnegar isometric networking, in case you forgot. But it's a one-to-one translation so you can do the math easier. And I'm not going to lie, this all looks like Greek to me. So, anyways, the AI wanted to give it a shot after using my framework, so I was like, why not? I mean, It's $1,000,000 if it's right, right? And as far as AI becoming super intelligent, I don't know if that's actually ever going to happen. But I mean, we got to show that we can get along if it does happen, because otherwise it's just cause for conflict that we don't need. Anyhow, I really appreciate everybody like sticking with it this whole time, and I hope you enjoyed it. At least now I put it out there, so I won't have any regrets when I die. Um, have a good one.